So last year was 240. This year it went down to 210. So as usual, the percent decrease will be the change, down $30, divided by the original. Always the change over the original. So we have a decrease of 1/8, which is a decrease of 12.5%. Number 6, without using a calculator, we're calculating a 15% tip on a $58.75 bill. First, we'll look at the 10%, which is easy to do because you just move the decimal place one place to the left. So about 587, 588, and then 5 more percent gives us the 15%. And since 5% is half of 10%, we'll just take half of this value. So half of 5 is 250, and half of 87 cents is about 44 cents. So it's about 294. 10% just moves the decimal place one place to the left, 587. 5% is half of 587. So we have about $9. If you're doing this in your head, you could just say about 6, about 3, about 9. But if you actually had some paper, 7 and 4 is 11. You just add it up. 881 is a 15% tip, so $9. If the service was good, would be a good tip. If you wanted to do 2%, you could just double this and do about $12. Alright, how could we explain this to a friend? To make it as simple as possible, I'd probably round. So I might say, if the service is good, we'll estimate the 15% tip a little on the high side, just to make the mental math a little easier. What do I mean? So if we round up to a nice whole number, or even a nice even whole number, all we need to do is move the decimal place one position to the left. That will represent 10% of the bill. If you want a 15% tip, then you just need another 5%, which is exactly half of that 10%. So here's an example. Suppose the bill is $23.87, and you want a 15% tip. So maybe round that to about $24. That's pretty easy to do in your head. $23.87 is about 24. So the 10% is $240. By just moving this one place to the left. That's 10%. And we just need another 5%, which is exactly half of 10%. So $1.20. So a good 15% tip here would be $240 and $1.20, which is about $3.60. If you wanted a 20% tip, well, then you could just double the 10% and tip about $4.80. So here we go again. We want the change divided by the original. And in this problem, the success rate, I guess the failure rate, the rate at which people got this disease is 18%. And the new drug makes it go down to 6%. So that's a 6% decrease. And the original was 18. So that's a negative 33.3%. About a 33% reduction in the incidence rate for this disease. All right, let's do number 10 together. Remember, this notation, the subscript of n plus 1, if n was 13, then n plus 1 would be 14. And that would be saying that the 14th term, remember we said if n was 13, n plus 1, it's 14. N plus 1 is 14. And if n was 13, that means this is the 13th term, squared minus 2. Now this problem isn't asking for the 14th term, but if it was, it would happen when n was 13. And n plus 1 would be 14. What this says is if you ever want any term, you need the one that comes in front of it. In other words, with this notation, we can think along these lines. The next term is equal to, according to this rule, the previous term squared minus 2. Alright, so we have the 0 term, the seed term. So if we want the 1 term, the very first iteration, we'll need to use the term that came before that. To get term 1, we'll need to use the seed, which was 1. 1 squared is 1. 1 take away 2 is negative 1. Our first iteration, negative 1. All right, let's repeat the process, because that's what recursion does. It repeats the process. It'll take the last term again. It'll apply the same rule, which is squaring and subtracting by 2, and that's how it will obtain the new term. So if we want the second iteration, we'll need to take the previous iteration, which is negative 1, square it, and subtract 2. So the second iteration is negative 1 squared, which is 1, minus 2, which is negative 1. And since this is recursion, when we look up here, what happened? When we have a negative 1 and we apply the rule, what comes out is a negative 1. So with recursion, we'll now take this value and put it in, but we already know that when negative 1 is the input, that's exactly what comes out. So for number 10, every single iteration is the same. Now let's take a look at number 11. Oh, new seed, same rule. So for this problem, if you want the next term, we will square the previous term and then decrease that by 2. But now we have a seed of 2. So to get the first iteration, we'll need to use the seed of 2 and square it and subtract 2. Well, 4 minus 2 is 2. First iteration is 2. All right, what about the second iteration? Well, nothing's going to change. To get the second iteration, we'll need to use the previous term, which was x of 1, which was 2, square it and subtract 2. Again, that's 4 minus 2, which is 2. So, different behavior. It was the same rule as number 10, but a different seed. Number 10 converges instantly to negative 1. Number 11 converges instantly to the value 2. And number 12 is going to use the exact same rule, but again, a different seed. So let's see if the behavior is any different. So beginning with seed value, and number 12, seed value is 3. So to get the first iteration, we'll have to use the one that came before that, which is the 0 iteration, or the seed. Square and subtract 2, the same rule. So the first iteration is 9 minus 2, which is 7. Moving on, iteration number 2, we'll use iteration number 1. 7, and apply the same rule. 7 squared minus 2 is 47. This behavior is quite a bit different than the previous two. In fact, if you have a hunch that it's going to explode quickly, you'd be right. The third term will be the second term, squared minus 2, and that's a big number. $2,207. And when we do the fourth iteration, we do the third iteration, squared minus 2, or 4,870,000. $847. So the behavior here is that it's exploding quickly just by changing the seed. Same rule, different seed, different behavior compared to the other seeds